Hello, and welcome to Elfinwood Data Science Blog. Elfinwood Data Science Blog is associated with Elfinwood Ecology, which is focused on data science, ecology, and conservation, and is based in Washington's Methow Valley. You can find Elfinwood Data Science Blog at elfinwoodecology.org by clicking on the blog button. You see the blog here with the post down below. Elfinwood Data Science Blog is associated with a GitHub repository, Elfinwood Data Sci /Learning Data Science. And here you can find instructions for forking this repository, cloning a fork, and updating your fork. And you can find the lessons in the lessons folder. Today's lesson is lesson 9. You can find the files associated with each lesson in the corresponding lesson folder. Today we'll be covering advanced filtering using where, and there's an annotated file here that has a series of examples of SQL select statements with different where criteria. So we'll jump right into the real quick overview of the YouTube channel. If you found this video, then you're aware of Elfinwood Ecology. If you like what you see, please subscribe and share it with a friend. Same with the blog. If you like the blog, please subscribe to the blog and share it with a friend. It's the best way you can support this blog. We're going to be working in pgadmin in My First Database. So if you've been following along on your own computer with all the blog posts and been keeping up with the various lessons, go ahead and connect to My First Database in pgadmin. Update your local repository and open up the lesson 9 file. And if you haven't been following along, no problem. That's what this video series is for, is to introduce folks to SQL and to this blog. All right, so in the lesson 9 file, this annotated listing of queries demonstrating advanced filtering using where, there's instructions at the top for how to use this file for learning and for if you're going to follow along. And we'll let you read through those on your own time and jump right into the first example here. The first example is a basic where clause using the equal sign. And so this select statement is selecting all columns from the public.site table where soil restrict layer code equals permafrost. So this will return only those rows where the soil restrict layer code column equals permafrost. So let's run that. And we get 424 rows. When we look at the soil restrict layer code column, you see that in all cases it's equal to permafrost. So our filter worked. All right, moving on to the next example. This is a basic where clause using the greater than or equal to sign. This query is selecting 3 columns from the public.sample table where elevation m is greater than or equal to 1000. And this will return only those rows where the elevation m column contains a value greater than or equal to 1000. So let's run that. We see we got 15 rows, and let's do a quick order by just to confirm that indeed all of these are greater than 1000. Okay, next example is a where clause using the AND operator. So it's the same query as above, we just saw, except we're adding an AND here, and we're saying we want the rows where elevation m is greater than or equal to 1000 and elevation m is less than or equal to 1200. And we're going to order by elevation m. So we get 12 rows now, and this returns only those rows where the elevation m column is greater than or equal to 1000 and where it's less than or equal to 1200. So we see that again, this meets those criteria. All right, so the next query will provide us the same result, but using a different approach. So in this next example, example 4, we're going to use the where clause with the between comparison predicate to express the range of values we are interested in filtering on. So this query will return the same results as the previous query, as I just mentioned. And so same query, except for the where, we're saying elevation m between 1,000 and 1,200. So that's equivalent to saying elevation m greater than or equal to 1,000 and elevation m less than 1,200. So we'll run this and see the result. Oops. Here, 12 rows, same rows, same criteria, different way to approach it. So, and note that between is inclusive of the upper and lower bounds specified in the where clause, meaning the results will include rows where elevation m equals 1,000 or 1,200, i.e. greater than or equal to 1,000 and less than or equal to 1,200. All right, on to example 5. So this is an example of using the where clause with the is not null predicate. And so, in database lingo, null means that data does not exist, meaning there is no value. Because there is no value, standard comparison operators won't work. For instance, equals, greater than, less than. These won't work with null. So you have to use this special predicate, is not null or is null. And so in this case, the results will so we're saying, select all these columns from the public.site table where site field note is not null. And so you can run that and see that in all 412 rows, there is a value in the site field note column here. And so this, the results contain only those rows for which the site field note column has a value, and i.e. is not null. Let's say we want to do the converse of that, and so we want to find all the rows where site field note is null, where there is no value. No field note was not recorded in the field. And we can use the is null, site field note is null. And we see that indeed all of these rows have a site field note that is null. So change that back and move on to the next. All right, number 6. So this is a where clause using the or operator. So we're saying select these columns from public.site where physiography value equals A or physiography value equals U. Now the following query will return only those rows where the physiography value column equals A or U. Run that, we see 385 rows. We see that all these A or U, A or U. So there's an example using or. All right, 7. So this is a where clause using the in operator. The in operator uses a set of one or more values as the evaluation criteria. So, so essentially what will happen is we're saying, so this is the same query as above, same columns, except we're using the in operator and saying where physiography value is in A, comma, U. So that's your list of values. And below this query will return all rows where the physiography value equals A or U. And the results are the same as the previous query. So this is essentially the same as saying physiography value equals A or physiography value equals U. Run that, and it's the same 385 rows. So, and then we can also look at the converse of that, which is not in, here at 8. So in this example, same query as above, except we're specifying physiography value not in, so we're using the in operator with the not operator, i.e. not in, which is the converse of in. So the below query will return all rows for physiography value except those that equal A or U. We run that, and we see that indeed R, L, P, anything in any value in physiography value column that does not equal A or U. So that's the converse of in, is not in. All right, so now we can start looking at the examples of the like operator. So this is the where clause using the like operator. And the like operator allows you to search for using wildcards. And so in this example, the % sign is used as the wildcard character, and the % sign matches any sequence of 0 or more characters. And so you pair a wildcard character with literal characters. So in this example, we're saying select study value sample ID from public.sample, where sample ID is like GAAR %. And so what this will do is this query will return all rows for which the value in the sample ID column starts with GAAR and ends with 0 or more characters. That's what the % is, the wildcard. So you'll see that the results here, I actually didn't run it yet. There we go. Let's run it. 173 rows. We see that the results, all of the rows have a value in sample ID that starts with GAAR. Okay, so let's look at another example. We're going to look at a couple more examples of the % wildcard. So in this example, so in this case, this we just looked at, the % was after the literal characters. Now we're going to look at an example where the % is placed before the literal characters. So in this case, same query as above, except we're saying like %, so your wildcard character, and then 2007. So what this query will return are rows for which the value in the sample ID column ends with 2007 and is preceded by 0 or more characters. So we'll run that. We'll see that indeed the end of the value here in all cases is 2007. All right, so we can also sandwich the literal characters between two %, as in the next example, example 11. And in this case, we've got a % before and after the literal character capital T01. And remember that SQL is case sensitive. So this query will return rows for which the value in the sample ID column contains capital T01 that is preceded and or followed by 0 or more characters. So we'll run that. We see that we get only 7 rows, but in all cases, capital T01 is located somewhere in that string. Okay, so another wildcard character used with like is the underscore. And underscores, that wildcard character matches any single character. So we see here in this example, we're selecting 3 columns from the public.site table where geomorph value is like underscore lowercase b underscore. And so what this query will do is return rows for which the value in the geomorph value column is 3 characters long with b as the second character. All right, so we see that the 7 rows returned give us values in geomorph value where b is the second character and they're all 3 characters long. OBC, LBG. Okay, example 13 is where we're going to use a underscore and a % wildcard characters in the same where clause. So in this case, we're preceding our literal character with an underscore and following it lowercase r is the literal character, and that's followed by a %. So what this will do is the rows returned will include those for which the value in the microtopo value column starts with a single character, followed by an R and ending with 0 or more characters. So there we go. There's your R is always the second character, and 0 or more characters at the end. So we can see, let's go down. Here's an example. These are all 3 characters long. This is an example where it's 2 characters long, DR. So that's the whole thing where it can be 0 or more characters. So that's an example of underscore and % used in the same where clause. All right, example number 14. So let's say that, because of these wildcard characters, % and underscore, there are also characters that you might want to find. You might want to use those in your criteria and actually find a backslash, or a % sign. And so in this case, if you want to match a literal underscore or % sign without matching other characters, then the character of interest must be preceded by an escape character. The default escape character is a backslash. So the following example will find only those rows in the public.site table where the site field note column contains a % sign. So we have select our columns from public.site where site field note like, so %, and then our backslash escape character. This is basically saying right here we want to find a percent sign. We don't want to find any character, which is what otherwise the percent sign would be. And we want to find that anywhere within the string, because we've surrounded the literal character by the percent signs. So let's run that. And so we end up with 9 rows, and in each case there's a percent sign somewhere in there. And see, lastly, let's just see an example where we didn't use the escape character. So if we didn't use the escape character, the backslash, then you would end up with 412 rows, and you'd end up with everything. All rows where site field note has any character. So basically, that's all rows where there's a field note, where field note is not null. It's a pretty big difference there. Okay, so last 2 examples are going to show some examples of the order of operations or precedence rules in SQL expressions. And so, basically, SQL expressions follow an order of operations or precedence rules similar to mathematical operations. In brief, expressions within parentheses take precedence over expressions outside parentheses, and takes precedence over or. So we'll look at 2 examples that look superficially similar, but that provide very different results. Number 16 here. So in this case, we have we're selecting our columns from public.site where physiography value equals lowercase l, and site ECUSCM is greater than or equal to 300, or site pH is greater than or equal to 7.0. And we want to order by sample ID. So note that there are no parentheses here, and we have an and an or. So the results will include all rows where physiography value equals L, and site EC is greater than or equal to 300. So this is gonna first process this criteria, because and takes precedence over or. Then it will process the or. And so the results will include all rows where physiography value equals L, and the site ECUSCM is greater than or equal to 300, plus all the rows, regardless of physiography value, with a site pH greater than or equal to 7. Let's run that. So we get 253 rows. And this may be what you want, but it may not. So just bear in mind that these precedence rules make a big difference, as we'll see in this next example. So essentially, this next example, again, let's just say 253 rows were returned in this example. So in the second example, it's nearly the same query, except that in the where clause, we're saying physiography value equals lowercase l, and in parentheses, site ECUSCM is greater than or equal to 300, or site pH is greater than or equal to 7. So in this case, what's in parentheses will be processed first, and then it will process the and. Let's run that. Oops, doesn't like the highlighting. Okay, so 18 rows versus 253 rows. Very different result set. And that is because in this statement, the expression within the parentheses is evaluated first, followed by the expression before the and operator. So then this query will first find all rows where site EC USCM is greater than or equal to 300, or site pH is greater than or equal to 7, and then within that set, we'll return only those rows that satisfy the physiography criteria. So we see we've only got physiography value of L in this case, and then our other columns here match those criteria. It's either EC is greater than 450 or site pH is greater than 7. If we go back to the previous example, we'll see that there's any number of different physiography values, not just L. P, L, U, R, A, so much less restrictive list. And so just bear in mind the takeaway here is how you write these where clauses and matter, and where you use parentheses, and to think about the logic behind what the results are that you want to see. So that's all I've got for today. Thanks for joining us, and we'll see you next time on Elfinwood Data Science Blog.